So what questions do we still have from yesterday's practice? Because I will also go back. I usually update the grades while in here. Harley? So landscaping one says that a landscaping company is delivering crushed stone to a construction site. The table shows the weight in pounds W of N loads of crushed stone. Which equation could represent the total weight in pounds for N loads of crushed stone? Do you have a specific question or just like? Okay, so in that case, try to see what math is being done to go from here to here. Okay, now on the number of crushed stone, looks like they're just going up by one each time. Over here, it looks like they're going up by how much each time? Yes, 2,000. So in that case, and that is consistent throughout, I would think that it's, well, let me think. So is it going to be this times 2,000 each time? Do you think that that is pretty consistent throughout? I think so too. So like I was gonna say, okay, well, I think it might be plus 2,000, but then multiplication is also repeated addition. So the fact that this is going up by one, kind of makes it easier to see, probably multiplication. And then see if it works. So only one of these even has, well, two of them have multiplication in it. These two do. See if for this equation, every time I plug in N, which was my loads of crushed stone, if I get what's in the W column. So like 2,000 times 0 is 0, 2,000 times 1 is 2,000, 2,000 times 2 is 4,000, 2,000 times 3 is 6,000. Is that what it says the answer is? Does anyone know? Okay. This one down here, like I just don't know where the 6,000 would even come from. That would suggest that like we started with 6,000 and that it's going down by 2,000 each time, when that's clearly not what's going on. As we increase the number of loads, the total weight increases. So this would not make sense to subtract. Okay, questions on that one? Any questions on other ones from this practice or really any practice? Harley? Okay. Which, what is it start with? Oh, this one. Okay, so members of the band sold juice and popcorn at a college football game to raise money for an out-of-country trip. The band raised $2,000. The amount raised is divided equally among the members of the band, which equation represents the amount that each member receives. So look for your signal words. The band raised $2,000. What they raised is not changing at all, so we should expect like the 2,000 to be in the equation. But it is divided equally among the members of the band. So divided equally would be what operation? Division, good. So we can eliminate that one and that one. Now for which one, you have to, like, if you're stuck on this and you're not sure, maybe see what could possibly make sense. Maybe even plug in some numbers in your calculator and see what could possibly make sense. Like say I have 20, or let's start with these numbers. Say I have 10 members in the band. How much would they each get if they're splitting $2,000? Would I have to do 10 divided by 2,000 or 2,000 divided by 10? They would each get 200, right? Then if I had like 20 members of the band, how much would they each get then? For it, I'm doing mental math. That looks good. Yeah, it is. So then what you're doing each time is you're taking the number divided by the people. You're not doing the opposite. You're not taking the people and dividing it by the 2,000, and then you're getting a really small number that doesn't make sense. Okay, questions on others? If you think of any other questions as we go, just let me know. But today's lesson was more about equations and what a solution means. So if you go back to that goal, what we know about solutions to equations. So when I tell you, for example, solve this equation, what exactly am I asking you to figure out? Maybe let me give you an example. Say it is 20 equals 2x minus 6. If I asked you what is the solution, it would be what? You don't have to like tell me what the number would be, but you tell me like what exactly I'm solving for. The value of the variable itself. Okay, so if I told you what's the solution to this, it would be whatever x has to equal in order to make this true. Okay, and I could actually solve it. So like start with what's farther, I would have to add 6 on each side, but do the opposite of what's being done. I get 26 equals 2x. Opposite of multiplying by 2 is good, and then so my solution is 13. Right, no. Yeah, 13. So that is my solution. A lot of the time, students will look at that and they'll be like, the solution's 20. All right, and it's not. Like, you just have to know what it means for something to be a solution. So when they say, could 13 be a possible solution? You could say yes, but it makes the equation true. And that's the gist. So the practice for today, the goal for today is an 80% or higher on lesson 4. I'll check in for the end of class to see what questions we have. But feel free to ask as you go. Any other questions though for right now? So 80% or higher on this one, but still like focus on all unit 2 puzzle pieces, because we do have a good one Monday over 2.1 to 2.4.
So now from the practice today, if you'd like to follow along, this one was asked. The one about volunteer drivers are needed to bring 80 students to the championship baseball game. Drivers either have cars, which can seat 4 students, or vans, which can seat 6 students. The equation describes the relationship between the number of cars, the number of vans, that can transport exactly 80 students, and you're going to select all that are approved. So if 20 cars go, no vans are needed. So what you'll have to do, which variable is for the cars? The C. So I would have to plug in 20 for the C. And then C, if that gives me enough to carry the 80 people. Does that make sense? What's 4 times 20? 80. So that alone does give me 80. So that means I would need no vans, right? Because 6 times 0 is 0. And then that would give me 80 equals to 80. So I would pick this one. And then the rest of these, and then I'll check every single one just in case. But it kind of sounds like you're just plugging in and seeing if it's true. So then if 10 cars go, so I'll use what I already have over here. If 10 cars go,
and 8 vans. I have to plug in 8 for the van. That will not be enough. So 4 times 10 is 40, 6 times 8 is 48. 40 plus 48 is 88. So would you agree with that statement, that that's not enough to transport all the students? If I have 10 cars and 8 vans, that seats 88 people. Sorry, hold on. Okay, so we're selecting all that are true. They're saying that 10 cars and 8 vans are not enough. Because I don't know why. It is enough in my opinion. Unless I do my math wrong. But if I have 88 seats, then yeah, I could take all 80 passengers. I have more than enough. Does that make sense? So I would not pick that one. If 6 cars go and 11 vans go, maybe I'll do that over here. 6 cars, 11 vans. Want that to have at least 80. It says there will be extra space, so let's see what 6 times 4. And then 6 times 11. And when I add that together, what's 24 plus 66? And is that true? Will there be extra space then? So then take that one. It says C equals 14 and B equals 4 are a pair of solutions to the equation. So solutions, remember, are values that make it true. So in this case, it would have to equal the 80. So I'm gonna try that. C will be 14. B will be 4. I feel like I need a calculator for this one. What is 4 times 14? All right, and then 56 plus 24, is that gonna be 80? So then in that case, these are solutions. They're a pair of solutions. So they would have to be plugged in and make the equation true, which they do. Then 8 vans and 8 cars are numbers that meet the constraints in this situation. Not sure what you're needing. Let me see what happens when I plug it in. I don't know if there's any kind of constraints. But let's see. 4 times 8 is what? 32. 6 times 8 is 40. And then 32 plus 48 is. All right, so I think what it means is it meets like my constraints, like my constraint being that there's 80 people that have to be transported. So I would say that that does meet the constraints. So I would also pick that one. And then if 12 cars go, then 2 vans are needed. So let's see. 4 times 12. I'll hold off on the V so far. But what's 4 times 12? 48. So I could also plug in 2 here and just see if that's true. I'll kind of do it a different way. I'll solve for V and see exactly how many I need. And in order to do that, I have to subtract 48 from each side. And 80 minus 48 is. You mean it shouldn't be positive? 48 minus 48. No, 80 minus 48. Oh, my bad. Okay, so 32 And then opposite of multiplying six. Oops, I did not mean to do that. Opposite of multiplying six would be dividing by six. So then if I do 32 divided by six, that means I need way more than 2 bands. I need about 5.3 bands. You can't have 0.3 bands. I would need 6 bands about. So I would not pick that one. I would pick these four, and let me see if that matches my key. And it does. So the 4 things that we said, I'll clear all of this. But yeah, the main point of today's lesson was knowing what it means when something's a solution. So when you plug it in, it makes it true. Questions on others? Cohen?
One by Diego.
Okay. Okay, so he is collecting dimes and nickels in a jar. He's collected $22.25 so far. The relationship can be shown by this equation. We're gonna select all values that could be solutions to the equation. And what might be different than what you've seen so far, but that you should get used to seeing from now on, is that it's in coordinate form, the way that they're showing the answers. But it does tell you that B is going to be for dimes and N for nickels. So that's how they're pairing each of these answers. So you're going to have to plug them into the given equation, which if you had to make the equation, hopefully you'd still be able to make it yourself. Because you know what a dime is in value and you know what a nickel is in value. And you're plugging each of these into the appropriate spots and seeing how many of these are possible answers. So what I would do is I would have Desmos up and I would type in the equation and then I would put parentheses for everywhere that I'm plugging stuff in. And then all I have to do after that is just change what's in the parentheses each time. So that's what I would do, and then if it equals 22.25, then I would select that as the answer. And you have to plug it in like exactly how it looks. So like on this next one, can't really have half a dime though, can you? So I'm automatically gonna eliminate that one because you can't have half a dime. But let me see if any others don't make sense. So yeah, I would just not even try that one. But like these other ones, you have to plug in exactly how they look. So like I would also plug in 118. And the 209 like that, and see what that equals. If it equals 22.25, then maybe it has an answer. Do I need to do more? Like, do I need to actually show you it in Desmos? Okay, because that's how you do it. And each time just switch the D in the end, like for this answer option, and you'll be set. All right, questions on others? If you do, let me know. Definitely try this. I'm gonna go back to my computer and also try it and make sure he is right. But yeah, if you have other questions, feel free to let me know. We're still in here till 12:30, so.